Good morning, everybody. Myself, Acharya Vishvendra, and today I'm going to discuss about the Poiseuille's equation for the flow rate through a particular tube. So let's begin with things in proper perspectives. So here is the worksheet on Poiseuille's equation. The first question is the volume flow rate, that is, volume flowing through a particular tube per unit time. So it is equal to pi p r4 by 8 eta L. This equation was derived by Poiseuille, that is why it is called as the Poiseuille's equation. Next now we have fluid resistance. So there is an analogy between electric current and the liquid flowing through a particular tube. As we know that current flows because of potential difference, so in the very same way liquid flows because of the pressure difference. And there is a certain resistance to the flow of liquid, that's why pressure difference has to be applied. So by analogy, that fluid resistance is 8 eta L upon pi R4. Now there are graphs related to the fluid resistance. The first graph is between RF and eta. You can see that it is proportional to eta, so the graph will be a straight line. If slope angle is theta, we can say that tan theta is equal to RF by eta. Substituting the values, we get 8 L upon pi R4. Next is graph between RF and L is a straight line again with tan theta is 8 eta by pi R4. Next is graph between RF and R. So it will be having a shape like rectangular hyperbola for both R as well as R4. Whereas if we draw graph between R4 fluid resistance and 1 by R4, that will be proportional to X, so graph will be a straight line. However, if you draw graph between RF and 1 by R square, so you take 1 by R square as X. So we can say that RF proportional to X square, so graph will be a parabola. Next is if we find dimension of fluid resistance. So after calculations, this is the dimension of fluid resistance. Next is SI unit. So we can say that kg meter minus 4 second minus 1 is the SI unit. CGS